Okay, good morning to everybody. Today we'll start with a new chapter, functions, limit and continuity. This is the actually first part. That means we will discuss only functions here. What is function? What are the types of functions? We will review this connecting to our previous lecture. So what is functions actually and what are the types of functions? So it is very important for us. That means define the following with examples: function, constant, variable, one valued function, explicit function, implicit function, algebraic and transcendental functions. These are four types. One is exponential function, logarithmic function, trigonometric function, and inverse trigonometric functions. Rational and irrational functions, monotony functions, even and odd functions, periodic functions, and composite functions, inverse function, continuous, and discrete functions. So we have to define it with examples. Then we can start what is limit and this. Maybe in these two maths we have done in previous lecture. So we will start with functions now. So what is function actually? All equations represent a relation between two or more variables. That means these types of xy equals to 1, x divided by 2y plus z equals to 0. So every equations can be represented like this. That means with the relationship between two variables. One is dependent variables and other is independent variables. The given two variables in relation, there is a functional relationship between them if for each value of one of them is one and only one value of another. That means for every input we'll get another output. Independent variable will give input and dependent variable will give output. So actually input and output, this relationship is called function. If the relationship between y and x can be shown by y equals to f of x. Suppose for each x we will get value of y. That means x has a relation with y. Y depends on x. Remember it. So x is input here and y is output. For each value of x, y will give output. That means for each value of x, there is an one and only value of y. Then there is a functional relationship between them, or alternatively, it can be said that y is a function of x, which means y as a dependent variable follows as x as an independent variable. That means from this definition of function, we will get only two variables. One is independent variable, where x is independent variables and y is dependent variables. So in every where actually we see function. So computer works on function, input processing, output. We are eating breakfast, we eat breakfast, lunch, dinner, etc., and this is processed, then we get energy. Okay, so every food is look like inputs, then it will be processed with our stomach, and then we get energy. Okay, so it's look like a function also. This is the actual example of real life. Now the idea of function is close to processing. That means matching. Machine look like a machine. It receives inputs, which I have talked with you, which are the values of x, and is called the domain of the function. Remember it. The set of all inputs x. The set of all inputs x is called domain, and it is represented by what? Df. And after the processing them, the output will be valued of y. Y will give the what? Output depending on x. In correspondence with x dash s, which is called range. This is the value, the set of all values of dependent variable. That means the set of all values of y is called range, rf. There should be no elements from domain without a match from range of function. This is domain of function. That means all the set of values of x, and this is the all the set of values of what? Y. Y gives range and x values give what? Domain. So this domain must be matched with what? Range. So it might be found by like free elements like range of f. Suppose x1, x2 dot dot xn all are the inputs. This is the inputs. First input, second input, x2 dot dot up to how many input? Xn input. So then this is the processing. That means function, and it will give output y1. X1 give y1 output, x2 give y2 output, x3 gives y3 output dot dot xn gives yn outputs. So this function, this diagram can be represented like this. A function equals to x1 comma y1, x2 comma y2 dot dot xn comma yn, and it will be represented as second bracket. Okay, this is the actually first element is the value of input, second value of coordinate what? Output. X1 input, y1 output. So this is the set. Another set what? X2 comma y2. Okay, so these types of function can be represented as like this with a set notation. Now functions can be considered as correspondence and matching rules which corresponds all elements of x to some elements of y. Okay, for example, the correspondence rule for function which corresponds to square root over x to each value of x can be written as like this. Function f is a function x to root over x. That means y equals to what? Root over x. This notation can be written as y equals to root over x. Here x is the domain and root over x will represent what? Range. Remember it. Suppose we are taking x value 1, 2, 4, 15, etc. 1, if x equals to 1, y equals to what? 1. Okay. If x equals to 2, y equals to what? Root over 2. If x equals to 4, y equals to what will be? Root over 4 means what? 2. If x equals to 15, then y equals to what will be? Root over 15. Okay. Root over 15. So suppose we get another value y what? 20. So suppose one match what? 1, because if x equals to 1, then y equals to 1. This is why 1 match, 2 root over 2 match, 4 2 match, 15 root over 15 match, but this 20 not match. This is why element of domain and element of y does not match equally. So in everywhere it may match or may not match. If all elements of domain will match to element of y, then it will be called 1 function, otherwise not 1 function. Suppose the correspondence rule which corresponds x square equals to minus 10, x square minus 10 to each value of x can be shown in like this. Suppose this is the another function of x to x square minus 10. That means y equals to what? X square minus 10. So every value of x, suppose x equals to minus 3, then y equals to what will be? Minus 1. If x equals to minus 2 whole square minus 10 what? 4 minus 10, that means minus 6. Then if x equals to 0, we get minus 10. If x equals to 2, then we get again minus 6. Okay. So if x equals to 3, we get only minus 1. That means this y, this function gives the diagram like this. That means for every inputs, there are more output. Suppose for input minus 2, we get minus 6 output. For 2 input, we get also minus 6. For 3 input, we get minus 1 output. For minus 3, we also get output minus 1. That means each element mapped to more elements, more than 1 elements. So this is the actually rules of function. So some correspondence rules indicate there is a relationship between x and y, but not functional relationship. Okay, there is no functional relationship. That is, the relationship cannot be considered as a function. For example, y equals to plus minus root over x. That means y square equals to x function. Y equals to root over x means what? Y square equals to x. Same words. Is not a function, because according to the definition of a function, for each value of x, there are two symmetrical values of y. Okay, so we get two symmetric values of y. That means for each value of x, we get more values of more than one values. This is why it is will be not function. Suppose if we plot this in a diagram, if x equals to 0, then y equals to 0. But if x is increases, then we get every value of y like this. If x is negative values -1, -2, -3 dot dot, then we get this. So for each values of x, suppose x equals to 2, we get two values. Suppose x equals to 4, we get two values. That means for each value of inputs, we get more than one values of y. This is why in this case it will be not function. So remember that for for every values of x, we get different values of y. Then it will be function. Otherwise, not function. So note that the graphical representation of a function, any parallel line with y-axis cross the graph of a function at one and only one point y. So which graph represents function actually? Okay, there are actually this is also function, but this is not a function because for every value of x we get two values of y. This is also not function. Okay, and this is also not function. For each value of x we get two values of more than one values of y. So power function, suppose y equals to x to the power n. N means what? 1, 2, 3, 4, etc. Okay, if n greater than 0, they all passes through the origin. Okay, if we plot, suppose y equals to x, it will be this line, y equals to x. That means y equal to mx line types. Y equals to mx what? The line which passes through the origin. That means this is the passes through the origin and make equal angle with the x-axis and y-axis. That means 45 degree. So if n less than 0, the function is not defined at x equals to 0. If x, suppose x to the -1, -2, -3 dot dot minus n, then it cannot be defined as a function. We have to remember this concept. Suppose exponential function. What is exponential function? We have studied. Y equals to a to the power x for a greater than 0, but not equals to 1. A greater than 0, a greater than, for every values of x we can plot. Suppose a equals to 1 by 5, a equals to half, a equals to 10, a equals to 3, then we can plot this. For every putting every values of x, we get another values of y. With the set of this, we can plot this graph. So all exponential function passing through the point 0, 1. Remember it. Passing to what? 0, 1. X equals to 0 and y equals to what? 1. Suppose this is the x-axis and this is the y-axis, but this is the 0, 0 origin point. So for x equals to 0, y equals to what? A 1. If a equals to 1, then we get this line. So every car passing through this line. Similarly, we can plot logarithmic function. Suppose y equals to log a base x, where a greater than 0 and not equal to 1. Remember it. So similarly, we can plot this for x equals to x equals to greater than 0, this, and x less than 0. That means y equals to e to the power x curve and y equals to ln x curve. So we can plot this, and remember this passes through the also 0, 1, 0. Okay, 1, 0. X equals to 1 and y equals to what? 0. If x equals to 1, then we get y equals to 0 because log 1 equals to what? 0. ln 1 equals to or log 1 equals to what? 0. This is why you get this one. Remember it. So similarly, trigonometric function y equals to sin x, y equals to cos x, y equals to tan x, and y equals to cot x, we can plot like this. This is the actually sine curve, and this is the tan curve, and this is the sec x curve. Okay, and this is the minus cos and minus cot and sec x. So for every putting every values of x in degree, we get value of y. Remember this, the values of y within -1 and 1. Remember it. But x values -infinity to +infinity. So domain will be -infinity to +infinity, but range will be what? -1 to 1 for sin x. Similarly for cos x also. Remember it, sin x curve passes through the origin, but cos x curve don't passes through the origin, it passes through the 0, 1. If x equals to 0, we get y equals to what? 1, because cos 0 degree equals to what? 1. This is why. So some basic functions, actually trigonometric function like this can be written as this, and all trigonometric function are periodic. What is periodic function? We have we will study in this part. Now elementary function, y equals to x plus 4x plus 1, y equals to these types of function actually is called elementary function. Behavior of a function. After finding the relationship between two variables x and y in the function like this, the first question is how the function behave. What types of function? That means types of function. Suppose slope of a linear function, y equals to mx plus a is, do you know, like this line? This is the straight line which passes through the not passes through the origin actually, but here m is the slope and s is the length which cuts from the y-axis. This is the length, and these types of curve y equals to mx plus c. This is the straight line. This is straight line. This is the geometrical interpretation. So here m is called slope. M equals to what? Actually, rate of change of y with respect to rate of change of x. That means if we suppose this is the alpha angle and this is the y-axis length, it's very small length del y, and another small length del x. This is the x-axis length, okay, and y-axis length. So y-axis run divided by x-axis run, what will be 10? Perpendicular by base. Perpendicular by base means what? 10. So m equals to can be written as 10 alpha in geometrically, but in calculus we can write as a rate of change. This is why it is called slope. Slope of a linear function is constant in its whole domain. Okay. Actually, for these types of function, m is the slope here, and s is the length of the intercept from y-axis. So slope of function in general form, suppose y equals to f of x. This is the y equals to f of x curve. Y equals to f of x curve. Suppose this is the tangent drawn from point A, then we can make an alpha length angle which makes with the x-axis. Okay, this is the x-axis. This is the x-axis parallel. So this increment can be written as functional increment f of x naught plus del minus f of x naught. Okay, for the increment of del x. Suppose this is the x naught and this length, total length, what? Del x. Okay, del x. So if this is x naught, then it will be what? X naught plus del x. For a little increment, del x. So this is for x naught we get ordinate what? This length what? F of x naught. But for the input x naught plus del x, we get input what? X plus del x, f of x plus del x. So this minus what will be? This whole length minus this length. So this whole length what? F of x naught plus del x minus this length what? F of x naught. So this small length will be what? F of x naught plus del x minus f of x. So the ratio of this given the change of x from x naught to x naught plus del x. Just and the y change, what will be? F of x naught and f of x naught plus del x. This means a movement along the curve from a point to b point for the increment of x naught to x naught plus del x. We get the y increment what? From a to b. We can plot, we can draw a triangle like this. So from this triangle, perpendicular by base, that means 10 alpha. Okay, this will give the actually slope of the or the average change of y in terms of x in, and can be calculated del y by del x equals to 10 alpha. Actually, this is the slope of line AB. Slope of line AB. And for this function y equals to f of x, the point will be x naught plus x naught comma f of x naught. This is the value of x, and this is the value of y for the value of a. Now actually after then we will study what is function, what is variable, what is constant, what are the types of function. Okay, So today we will start this chapter, actually first chapters for final exam: functions, limit, and continuity. And this is the first part. That means we will discuss about functions. Okay, what will be the definition of functions? What are the types of functions? Actually, we'll discuss in this part. And this is chapter 6, actually. Function, limit, and continuity. This is the book chapter, B.K. Kapoor. First of all, we'll discuss what is function from this chapter. So what is function actually? A function is a technical term used to symbolize relationship between variables. When two variables are so related that for any arbitrary assigned value to one of them, there corresponds to a definite value for the other. The second variable is said to be the function of the first part. That means what is function? A function is a relation between two variables. You can write down now the definition. What will be the definition of function? A function is a relation between two variables. Okay, one variable is independent variable, another variable is dependent variable. Okay, so the idea of the function is sometimes expressed as the relation between two real variables, say x and y, which are so related that corresponding to every value of a of x defined as the domain, we get a finite value b of y defined as the range of y as said to be the function of x. Okay, suppose y equals to f of x. This is the actually mathematical representation of function. For every value of x, we will get another value of y. That means x is input and y is output. Okay, for every value of x, we will get any value of y. That means x is input and y is output. On the other hand, the set of values of x is say domain, and the value of the set of the values of y will be range. And actually this is the relation between x and y. So x is the independent variable and y is dependent variable. Okay, so the relation between two variables like this is called function. Actually this is the example. This is the example of function f of x equals to x square plus thrice x minus 7. If you put x equals to any values, minus 1, 2, 3, 4, etc., dot dot up to infinity, and minus 1, minus 2, minus 3, dot dot minus infinity, then you will get another value of f of x. Okay, so this is the relation between x and f of x. So it is a function. Now, what will be the constant? The symbols, this is the constant, definition of constant. The symbols which retain the same value throughout the set of mathematical operations are called constants. Actually, suppose this 7 is a constant, minus 7 is a constant, and this 3 also constant. If we take any operation for this, suppose x equals to, we are changing x equals to 1, x equals to 2, x equals to 3, but this 3 and minus 7 will not change for every operation. This is why this 3 and minus 7 is called constant. So there are two types of constant, absolute constant and arbitrary constant. And this is very important definition for you: absolute constant, arbitrary constant. So constants are actually two types. One is absolute constants, those which have the same value in all operations and discussions. For example, pi, root over 2, etc. And e also, Euler numbers are all absolute constant because this is used independently in everywhere. Okay, this is called absolute constant. Pi value what? 3 point something dot dot, and root over 2. Okay, root over 3, root over 5, etc. are called absolute constant. Arbitrary constant, which will be those which may have any assigned value throughout a set of mathematical operation. For example, the radius of a circle or the side of a right angle triangle in forming trigonometric ratios are the arbitrary constants. Okay, so these types of constants actually, so suppose radius of a circle, diameter of a circle, etc. are arbitrary constants. Now what will be the variables? What will be the variables if a symbol x denotes any element of a given set of numbers, then x is said to be a variable. Suppose we have discussed this is a function f of x equals to x square plus thrice x minus 7. Here x is the variable. Okay, remember it, x is independent variable. Okay, and f of x means what? Y is dependent variable because y depends on x. This is why in this function x is independent variable and this f of x or y will be what? Dependent variable because this f of x value depends on x. Understand? Depends on x. This is why f of x or y will be dependent variable. So the symbol of variables, a few alphabet x, y, z or u, v, w, etc. Okay, there are also dependent variable and independent variable. There are two types of variable. Okay, now what are the types of function? Now we'll discuss actually what are the types of function. Okay, now we'll learn what define the following with examples. Suppose functions, constants, variables, one valued function, explicit function, implicit function, algebraic and transcendental functions, exponential functions, logarithm function, and trigonometric, inverse trigonometric function. Actually, these four types, exponential, this function, these four functions actually algebraic and transcendental function. Okay, there are four types of algebraic and transcendental functions: rational and irrational functions, monotony functions, even and odd functions, periodic functions, and composite functions. Okay, then inverse functions, continuous and discrete functions. We will try to define this with examples now. So first of all, what is function? We have studied it is variable and constant. Now types of function. One valued function. What is the actually one valued function? Actually function means relation between two variables. We must know about this. When a function has only one value corresponding to each value of the independent variable, the function is called one value function. Okay, suppose if y equals to x, for every value of x we get another value of y. That means y is a single valued function of x. Okay, remember this, if y equals to root over x, then y is a two valued function of square root over x, because square root over x means what? Plus root over x or minus root over x. There are two value because in every square root we get two values of x. This is why y is the two valued function, and here in first example y is a single valued function or one valued function. Now what will be the explicit function? A function expressed directly in terms of dependent variable is said to be an explicit function. Okay, the function expressed directly in terms of dependent variable. What is dependent variable? Y. Y is the dependent variable of functions, and x is the independent variable of functions. Remember it. So these types of functions, suppose y equals to x square plus twice x minus 5. Okay, x is the independent variable and y is the dependent variable. So y can be expressed directly in terms of dependent variable. It's called explicit function. This is the example of explicit function. Remember it. And this also explicit function, and another function as implicit function. What is implicit function? Okay, another one, the function which not expressed directly in terms of dependent variable. There is mutual relationship between two variables, and either variable determines the other is said to be implicit function. That means we cannot directly expressed as a dependent variable. Okay, we cannot directly express with the dependent variables. That means twice x minus thrice y equals to 0. Actually they are mixed with variables. We cannot express this in terms of dependent variable. Suppose x square plus y square equals to 16. This is also cannot be expressed as dependent variable. Okay, this is why it is the example of implicit function. Okay, what is implicit function? Opposite of what? Explicit function. Now what is algebraic and transcendental functions? Okay, functions may be also classified according to the operations involved in the relation. Neglecting a function and its dependent variable or variables. When the relation which involves only a finite number of terms and the variables are affected only by the operations addition, subtraction, multiplication and division, powers, roots, etc., the function is said to be algebraic function. Suppose these types of function we discussed in all types of function like this is a algebraic function of x. Just we are expressing with the variable x. All the functions of x which are not algebraic is called transcendental function. Remember it. The function which cannot be expressed as algebraic one, then the function are called what? Transcendental function. Remember it. Now what will be the transcendental function? There are four types of transcendental function. One is exponential functions, logarithmic functions, trigonometric functions, and inverse trigonometric function. These four types of functions is called what? Transcendental function. Exponential means what? Like this, sin inverse x into e to the power twice x. Logarithmic function what? Log x. Okay, y equals to what? Log x, log present. This also logarithmic function. Trigonometric function what will be? Cos x, sin x, tan x, etc. Okay, y equals to cos x, y equals to tan x, y equals to sec x, etc. Trigonometric function. Now inverse trigonometric function, tan inverse, sin inverse. Okay, sin inverse. This is the inverse trigonometric function. So there are four types of functions of what? Transcendental function. Remember it. This is the definition of transcendental function. Now rational and irrational function. Rational and irrational function. Expressions involving x which consist of a finite number of terms of the form a into x to the power n. Suppose a into x to the power a means any constant, any numbers. A into x to the power n. That means what? 4 into x to the power 4. 3 into x to the power 3. That means a into x to the power n types. This is also. In which a is the any constant and n is a positive integer. Positive integer. Then these types of function is called a rational integral function. That means a rational function. Okay. Now, when an expression having more than two terms but only one variable x, in all types, here also only one variable. Okay, one variable x, only one variable consists. This is why these types of expression is called polynomial. Poly means what? Many terms here. involving x. This is why this is polynomial in x. Okay, where a0, a1, a2, and dot dot m are constants, and m is the degree of polynomial. Where m is the degree of polynomial. Suppose m is 4 here in this function, in this expression, m is 4. This is the algebraic expression, and 4. This is the 4-degree polynomial. If highest power is 3, then 3-degree polynomial. If highest power is m, then m degree of polynomial. Okay. Now rational function, what? If the expression in x, in which x is positive integral exponents, only a finite number of terms, including the division p by q types function. P by q types function is called rational function. Okay, some numerator divided by denominator. This types of function is called rational function. An expression involving x which involves root extraction of terms is called irrational function. That means root over x, root over some expression, these types. That means if square root involves in any function, then those types of function is called irrational function. Okay. Now, suppose twice x square plus 1 and 2 plus 1 by x are rational function, but root over x plus 1 and x to the 3 by 2 plus 1, this is the integral power. Okay, so this is also called irrational function. Remember it, not rational. Now monotony function, what will be? Monotony function, if the a function is called monotony decreasing function in an interval, if an increase in the value of x always brings out decrease in the value of function in the interval. Thus, if x1 and x2 are only two numbers in the interval such that x2 is greater than x1 and x2 may be any numbers, okay, 2, 3, 4, 5, etc. numbers. Then if x2 is greater than x1, then f of x is said to be monotonically increasing if fx2 is greater than f of x1 when it's satisfied. Okay, if it is opposite, that means f is monotonically decreasing if this is opposite, f of x2 less than f of x1. Now what will be the even and odd function? If a function f of x such that f of minus x equals to f of x, okay, then if any function satisfies this condition, then it is said to be even function. Suppose f of x equals to x to the power 4. If we replace x equals to minus x, suppose like this, I am trying to show you. Suppose we are given y equals to example of even function and odd function. Okay, example of odd and even function. Example odd and even function. Okay, let y equals to f of x. Y equals to what? Suppose we have y equals to Microsoft Math equation is not available now. Hello, are you watching? Suppose y equals to x square. Okay, x square. Y equals to x square. That means f of x equals to what? F of x equals to what? X square, right? F of x equals to x square. Now, if we take f of, suppose f of, I have f of -1 minus x, then what will be the values? Bracket minus x whole square, right? Bracket minus x whole square. That means this equals to what? This equals to what? This equals to x square, right? Right? That means this equals to what? F of x, right? If we replace minus x here, then it's become again f of x. So this types of function is called actually what? Even function. Understand, everybody? These types of function what? Even function. Similarly, we can write it for, suppose we have another function for this 4 y equal to x to the power 4. That means f of x equals to x to the power 4. So if we replace this with minus x, okay, then we get again x to the power 4. That means f of x. Because if the power is even, then minus will be absorbed. Okay, minus will be cancelled because there are 4 minus 4. If we take 4 minus with multiplication, then it will be plus. This is why x to the power 4. That means these types of function is called actually what? Even function. Okay, even function. Understand? So what is even function and what is odd function? So the even and odd function, if a function f of x is said to be f of minus x equals to f of x. Actually, we have shown an example with this. Then it is said to be an even function of x. That means this x to the power 4, 5x square, 7x square plus cos x, etc. are all even function. If we suppose f of x equals to this, then you can, I have shown you, f of x equals to minus 5x square. Then if we replace minus x by minus x, then we get the original function. So now if a function f of minus x is such that f of minus x equals to minus f of x, okay, f of minus x equals to what? Minus f of x, then these types of function is said to be an odd function of x. For example, x cube, 5x plus 6x cube, sin x, etc. are all odd function. Now we can show an example of odd function for you. Now what will be the actually odd function? Okay, suppose we have y equals to x cube, y equals to what? Suppose we have y equals to x cube, that means f of x equals to what? X cube, right?